In this video, we're going to look at angles in parallel lines. Let's start off with some basic angle facts. If I take a straight line and we have two different angles, A and B, we can say that these two angles will sum to give 180 degrees. Angles on a straight line sum to give 180 degrees. So if this is A and this is B, then we can say that A plus B will be equal to 180 degrees. If we now look at angles about a point, so if I just draw a point, we can say that angles about a point sum to give 360 degrees. So if I just put some angles on here, we'll have that one, we'll have this one, and then we'll have one more up here. If we add all of these will give us 360 degrees. So if we said that this was going to be A, this one here was going to be B, this one was going to be C, and this one was going to be D, we can say that A plus B plus C plus D will be equal to 360 degrees. We've done one entire revolution. If we now look at opposite angles are always equal. So if I have now an angle just here, so let's put this on, I'm going to say that this is going to be angle A, then the opposite angle just here will also be equal to A. So for example, if we said that A was 85 degrees, then both of these would be 85 degrees. I'm now going to put B on. B will be equal and opposite to the B. And we know A plus B on a straight line will sum to give 180 degrees. So we can say from here now that opposite angles equal, A will be equal to A, B will be equal to B. Let's now look at a triangle. The angles in a triangle sum to give 180 degrees. So all I'm going to do is write this on, and we'll just pop these on. So if we have this angle just here, we will have A just here, we will have B just here, and we'll have C just here. We can say that A plus B plus C will be equal to 180 degrees. If I see some lines here, we can say that this is an isosceles triangle, and we could say that C would be equal to B. If this was an equilateral triangle, we could say that C would be equal to B, which would be equal to A. They would all be 60 degrees. Generally speaking though, the angles in a triangle sum to give 180 degrees. What we're now going to do is look at some angle facts when we have parallel lines. I'm going to draw 3 of these up, and these should form part of your notes. So what I'm going to have now are parallel lines, and I'll draw some sets of parallel lines. I'm now going to draw what we call a transversal. A transversal cuts the parallel lines. We can denote the parallel lines with little arrows like so. So if you see 2 lines with the arrows, it says that these 2 lines are parallel. The first type of angle we're going to look at is alternate angles, or Z angles. If we have this angle just here and this one, I'm going to call this A. This too will be A, and we call these alternate angles. So alternate angles. Sometimes you will hear them being called Z angles, but do check with your exam board if they allow it. So these are Z angles. So for example now, if we said this was 75, this would be 75. We can go round and look at other sets of alternate angles. This one will be an alternate angle with now this one. So that one and that one will be another one. So we could say that this would be and this would be B. It's easier to see why we would call them Z with the A's, but B and B are also alternate angles. So if you're slightly unsure of why that's the case, let's just go ahead, and I'm going to draw now. If we look at this here, the reason they're called Z is because we have now this part right here. If you want to think about that as a backward Z, you're more than welcome to do so. So those ones are alternate angles. Alternate angles are equal. Let's go ahead and look at some more angle facts. So again, I'm going to have some parallel lines, and I'm going to draw a transversal. So a transversal just crosses like so. I'm going to denote my parallel lines by simply writing the arrows on, and we're going to have the following. I'm going to take this angle just here, and I'm going to take this one just here. I'm going to say that this one is going to be A, and this one also is going to be A. We call these corresponding angles. So these are corresponding angles, or we can call them now F angles. So let's put that in. So F angles. Check with your exam board if you're allowed to use F angles. So on here we can see that A is equal to A, B is equal to B, exactly the same here. A is going to be equal to A. So if this was 130 degrees, this one too is going to be 130 degrees. We could look at lots of different ones in here. We could look at more. We could look at this one with this one. We could go ahead and look at that one. So if we wanted that one with that one, and we wanted to say that this was B and this was B, those two are corresponding angles. And we know that A plus B is going to give us 180. If you're unsure on the whole idea of why they're called F angles, let's put that there. If we just draw a cross, then it looks like the letter F. So those are corresponding angles. Let's now look at co-interior angles, or C angles. Again, with my transversal, what we're going to have are two parallel lines. So two parallel lines, here's my transversal, and I'm going to put on now the arrows denoting that these are parallel lines. So let's go ahead. I'm going to have this one and this one. I'm going to say that this is A and this is B, and we can say now that if these are co-interior angles, so co-interior, so just jotting this down, co-interior angles, and we say sometimes that these are called C angles, then we can say A plus B will be equal to 180 degrees. We can see how it works from this one quite clearly. We know that A and A are equal, B and B are equal, and we know that angles on a straight line sum to give 180 degrees. So we can see that these co-interior angles trapped inside our C are going to give us 180 degrees. So these are the angle facts that we're going to use throughout the video, and ones that you're going to have to learn. So what we're going to have, just putting this on if you're unsure on the whole idea of C angles, that's what we've got. So they add to 180. So Z angles or alternate angles are equal, corresponding angles are equal, and co-interior angles equal to 180 degrees. If we just look at an app that I made, this shows us now how this works. So if we look now, we've got these ones here. So the blue ones are Z angles or alternate angles. So if I move the transversal, we can see that they are always going to be equal. So here are my parallel lines. We've got our parallel lines, and I'm just moving that round, and we can see 45.68, 45.68. So wherever they go, they will be the same. If we look at these ones here, these are examples of corresponding angles, or the F angles. Again, we can see that those are always equal. If we look at the yellow ones, these are the co-interior ones, or the C angles. So we have our parallel lines, and then we have the transversal. They will always sum to 180 degrees. When you're solving problems with parallel lines and the angles, there are so many different ways to do it. In the video, we're going to look at different ways to do it, and often we're asked to show or write down why they were. So if you do it one way and someone else does it another way, it doesn't matter as long as you're quoting basic angle facts. So let's go ahead and look at some. So what we need to do in this one is find A and B. So straight off, you could say to yourself, well, A and 57 are opposite angles, so A would be equal to 57 degrees. You could have gone the other way and said, well, I have a straight line here, and I know that B plus 57 must be equal to 180 degrees, so B is going to give me 123 degrees. So entirely up to opposite angle with A, or you can say it's on a straight line with B, and that would give us now our 180 degrees. When you're asked to explain why, just saying either of these two facts will get you the marks. So that one's nice and straightforward. We need to find the value of A. If we look here, we have F angles or corresponding angles. It falls into this one right here. So if we look, we've got A just here and we've got A just here. So we can match that up with what we've got. We can say now that these two are going to be equal. So in that case, ours would be the B and the B. So we could say now that these are both 50 degrees. So A is equal to 50 degrees. And if I was asked for a reason, we could say they were corresponding. So corresponding or F angles. So writing this in corresponding and then F angles. So they are equal. So if you're asked for a justification, that is your reason. 1 mark often for this, 1 mark for that. So nice and straightforward. And if it said now find the angle just here, B, then that would be 130 degrees. Either because angles on a straight line sum to 180 or because we've got co-interior angles. Okay, so let's go for this one. 120, A, B and C. With all of these problems, you don't have to do them in alphabetical order. Straight off, I'm going to find A. A is going to be equal to 60 degrees. Angles on a straight line sum to give 180, so A is 180 minus 120. At this stage, I'm going to say that B, so B is also going to be 60 degrees. The reason B is 60 degrees is that A and B are corresponding angles. And if you wanted to put this in, let's just write this in. So A and B are now, and I'm just going to write F angles. As stated in an exam, write corresponding angles. Then from here, I can simply say that C is going to be equal to 120 degrees. Angles on a straight line sum to give 180. So if B is 60, C is 120. That is one of the many, many ways that you could have done this. Again, different people see different things differently. You might say, well, that's 120 degrees because it's an opposite angle to 120. And then what we have here are our corresponding angles. So this too must be 120 degrees. I wouldn't personally see it that way, but it's one of the many different options that you could use. Okay, so let's look at this one. Now this one's on a turned round. In the exam, if you think that you can't see it too well, just spin it round. So if you wanted to go back to that and you see that easier, go ahead and do it. Do be careful which lines are parallel. It's not much of a problem with this one, but sometimes students get confused which ones are which. Okay, so let's look at this. This now is a corresponding angle. Probably easier if I do spin it back that way to see it. So now we've got F angles. So there are my parallel lines. So this one with C is going to be a corresponding angle. So straight off I'm going to write that C, in pencil in the exam, C is going to be 25. So from here I can say that C is going to be 25. A is an opposite angle, that's going to be 25. And C and B, or A and B, are on the straight line. So these need to sum to 180 degrees. So this would be 155 degrees. So these two are on a straight line, so they sum. These two are on a straight line, so we can just write those down. I'm not going to write justifications, but if you're asked, there are lots of different reasons that you could state. Okay, what's going on with this one? A, B and C. As stated, you can start where you like. I'm going to start with A, as I know that the angles on a straight line sum to 180 degrees. So 20 and A is 180, so we can say that A would be 160 degrees. I've simply taken now the 20 degrees from 180. At this stage, I can use I can use 3 different ones. I can say that B is a co-interior angle with the 20, so it would be 160 degrees. I could say it's a corresponding angle with A, or what I could do is find C, because C is a Z angle, alternate angle with the 20, and then go from there. It's entirely up to you, and as stated, the way one person does it is not necessarily that a way another would. So for example now, what I could say is my alternate angle, my Z angle just there, 20 and the C are the same. So I could go that route. If I didn't fancy doing it that way, what I could say is that I've got C angles, so co-interior angles, the technical name. My co-interior angles, B and 20 must be equal to 180, or I could do the corresponding angles, which are the F angles, and look at the F angles with now the B and the 120 that I found, the 160 that I found earlier. So entirely up to me, I'm just going to write this down. This one is going to be 160 degrees, co-interior with the 20. This one is going to be 20 degrees. Angles on a straight line sum to 180, or this is an alternate angle, a Z angle with the 20. So you make up your mind, and if you're asked to justify it, you've got so many different ways. Okay, let's look at this one. Here are my parallel lines. Now this is what often catches students out. The parallel lines are here. The transversals now are these two lines. These are not the parallel lines. So let's go ahead and do this. We don't have to do it alphabetically. It's entirely up to you. Opposite angles, 60 degrees. A is going to be 60 degrees. Opposite angle, we're going to have C is 70 degrees. I'm now going to look at co-interior angles. So if we look at co-interior angles, I can see now the following. So my co-interior angles are going to be just here. So I've got those two, which are going to add to give 180. And then I've got these two just here. So C and B add to give 180, and A and D do. A and B do not sum to 180, and that's a common error students make. So this one right here would be 120 degrees with our co-interior angles. These now two need to sum to 180, so B is 110. Don't fall into a trap here. You can see quite clearly they do not now equal 180. These two do not sum to 180 degrees. Okay, let's go for this one. Now this one, we got a bit more information on. We're told these two lines are parallel, so we got this one with this one, so these two are parallel, and then we have the other two that are parallel. So this one with this one right here. So we've got a parallelogram. Parallelogram, a side now, two sides the same at the top, two sides the same at the side. So let's put this on. So opposite angles, 52 degrees. With our parallelogram, we can say that the opposite angles are going to be equal. So if this is 52, A is also going to be 52 degrees. We can now use co-interior angles, so we're left now with 128 degrees and 128 degrees. So we can see there are multiple co-interior angles. If you're really unsure, you can just keep going around this and it makes perfect sense of why. If we've got this angle just here, this one here is going to be exactly the same. We can see that this one here will be the same as the 52 as their corresponding angles. So you can see how it's going to build up. You could say that this angle right here is an alternate or Z angle with the 52. Make sure all of your angle facts add up. So for example now, if these two didn't sum to 180 degrees, then we'd have to think, what have we done wrong? So using angle facts, parallel lines, and also now shape properties to work that out. Okay, right, got lots going on here. Let's see what we've got. We've got our two parallel lines, so we can see our parallel lines are here. I've got now an angle given here of 60, 50, and we need to find the other ones. The first thing I think to myself now is, what can I do with this? I know that angles in a triangle sum to 180 degrees. I can start where I like. I don't have to start with A. Starting with A is probably a lot harder than it needs to be. So if this is 50 and this is 60, that gives me 110 degrees. So this one here must be equal now to 70 degrees. 70, opposite angles, 70 degrees. At this stage, I've got lots of different choices. This is an opposite angle, and that is going to give me 50 degrees. Let's now look at this angle just here. I could use a number of different approaches. This angle with this one is going to be a corresponding angle, so we can say that this is 70 degrees. Opposite angles, 70 degrees. I've got now a straight line. The angles on a straight line sum to 180 degrees, so 70 and 50 is 120, and that gives me 60 degrees. There are so many different ways that you could do that. Let's just look at this angle just here and this one just here. Well, they're corresponding angles, so they must be the same. You might do one of these questions and come back to it 30 seconds later and see a much quicker way. There might be a much quicker way to that. I could have gone this way round, I suppose, and said, well, if this is 60, then this is 60 because these are alternate or Z angles. Angles on a straight line from there, and just now match them all up. Okay, so that's one way. If you see a quicker way, feel free to do it. If you're asked to explain, state what you're doing at each stage. Okay, what we're going to do now is do a longer-winded example. So what I'm going to do is justify each one this time. So what we're going to have then is the following. Let's justify. So I need to find A, B, C, D, E and F. We've got our parallel lines. So here's our transversal, here's another transversal. The first thing I'm going to do is write here that this is 90 degrees. So 90 degrees. I've got a right angle and I'm going to go from there. So what I can say now is B. If I start with B, so starting with B, B will be equal to 180 minus 90 minus the 42. And you can say angles sum, so angles in triangle, I'm just writing it here, sum to 180 degrees. So we could go ahead, if we were asked to now articulate this. So in a typical exam question, it might have an asterisk. So we need to say what we're doing. So what's that going to give me in total? B is going to be equal to 48 degrees. So B is equal to 48 degrees. I'm just going to write that on so I can see, again, writing this on in pencil in the exam. So this is going to be 48 degrees. And the next thing I'm going to do is look at angle C. C plus B will be equal to 180 degrees. And we can say angles now, so angles sum to 180 degrees on a straight line. So on a straight line. So just jotting this in, straight line, and we've got that. I'm going to use the symbol for therefore, so therefore, which you don't have to, we're going to have now from here that we will have C, so let's write in, C is going to give us now 100, what's that, 132. So C will be equal to 132 degrees. So that one is done, and we can put that on. So let's go ahead, put that on, 132 degrees. If we look at A and B are opposite angles, so we can just simply write here A, opposite angle, so opposite to B, and therefore we can say that A is equal to B, which is going to give 48 degrees. So opposite angles are equal if you want to state that. So you can see how we can build this up and just writing these down. So this is 48. Remember, we still need to make these two add up now to 180 degrees. So at this stage now, we need to find the others. And it's entirely up to you on how you want to approach this. If I look now with F, and I'm not going to write much more here. If I look with F, I've got B, so B is just here. And putting this on, we can see that F is also going to be 48 degrees. So this is going to be 48 degrees as F and B are corresponding angles. They're F angles. If we want to now find D and E, lots of different approaches. What I could say now, you might see it differently. I'm going to say that D plus the 42 here will be equal to 180 degrees. So we can say that D and now the 42, D and 42 degree angle are co-interior. So these are co-interior, and that is going to give me now an angle here of 132 degrees. So this one is 132 degrees. We could instead have said now that this angle just here, the 42 and the E, are corresponding angles, which would give me 42 degrees. Lots of different approaches with this. You might have even gone this way round and said that that is 48, that is a right angle, and then you could have found this angle here to be 42, opposite angles, and then gone from there. As you can see, there are so many different ways to do this. There's no one wrong or right way. It's entirely up to you. You could have even used similar triangles. We have now similar triangles just here. So this one with this one and gone that way. It's entirely up to you. So as stated, if you're asked, I've started building up an answer. There's lots of them to do, but hopefully that's given you an idea on how you can do that. Okay, let's look at another one. Right, so let's look at this one here. We've got now some algebra, 4x and 2x. What I'm going to do is find the value of x. So we can say now that this angle right here is going to be opposite. So this one is going to give me now 4x. So what I have is 4x just here. I'm going to say at this point now, and if we were asked, I would structure my answer. I'm now going to look at co-interior angles. So co-interior angles will be equal to 180 degrees. So just writing this down, so co-interior or C angles, so co-interior C angles equal 180 degrees. They sum to give 180. So we can say 4x plus 2x is equal to 180. So we got 6x will be equal to 180 degrees. So x is going to be equal to 180 divided by 6, which is 30 degrees. So if we look at these now, the value of x is 30 degrees. Does that kind of look right? Well, that looks about 2 lots of 30, which is 60. Does that look about right? That looks like about 120 degrees. So always check what you're coming up with. Make sure it's sensible, but that seems pretty good. Remember, despite these not being drawn accurately, there's some limitation. So for example, if this was now 4x and we said that's 120 degrees, clearly 120 degrees is going to be somewhere out here. So a nice bit of algebra using parallel lines. You could have gone so many different ways with this. You could have said, well, this angle right here is going to be 2x because 2x and 2x are alternate angles. Then we've got now 4x plus the 2x must sum to give 180 degrees as angles on a straight line sum to 180, and we're left with the same thing. You could probably actually do it for every possible angle fact that we've looked at. As long as you're consistent and you give an explanation, you will get the marks. Okay, let's see what else we've got. So this question says, in the diagram, xy is equal to zy, and zy is parallel to xw. In part A, we're asked to write down the size of angle P. So if we just look, and I'll just do this now, what we've got then are our two parallel lines. So our parallel lines are just here. So that's our parallel line, and that's our parallel line. So essentially we have this as a transversal. What's also interesting about this one here is that I have a little dash here and a little dash here, and that tells me I have an isosceles triangle. So write down the size of angle P. So that's made it slightly easier for me, as I can tell our isosceles triangle is here. So that gives me now that the base angles are going to be the same. So 48 degrees is P. These two angles are the same. Okay, we're asked to calculate the size of angle Q. Give a reason for your answer. Well, 48 plus 48 will be equal to 96 degrees. 180 minus 96 degrees is going to give us 80, and what's that going to be? That's going to be 84 degrees. Angles in a triangle, so angles in a triangle sum to 180 degrees. Angles in a triangle sum to 180. We don't need to state anything about an isosceles triangle, purely based on the fact that we were asked to write down the size of angle P in the first part. We've already shown that it's an isosceles triangle. So calculate the size of angle Q, give a reason for your answer. Well, it's going to be now the 180 minus these two added, and then subtract now. So that gives me 84 degrees. Okay, give a reason why angle Q is equal to angle R. So what we have here is the following. We've got Q, and now, in fact, let's just change the colour of that to make it nice and easy to see. We've got angle Q, and we've got angle R. These are alternate angles. If I just extend now the pink line here, what we've got is parallel lines. These are parallel, we know they're parallel, and we've got a transversal. So the transversal here, and let's put the transversal on, the transversal is that. So we can see that this angle right here will be equal to this one, which is going to give us 84 degrees, and we can state because angle Q and angle R are alternate angles. So there we go, some work with angles in parallel lines. Lots of different ways to do things. Make sure you're stating why if you're asked, and just check that all of the angle facts add up. So for example, now if you found this one a different way and they didn't add to give 180 in a triangle, check what you've done and go back.